Guys, welcome back to Chemistry TV. Let's look at aldehyde and ketone. So in this video, yeah, I'm going to show the difference between aldehyde and ketones, the structure and the nomenclature. Because that if you really want to understand aldehyde and the ketone, the preparation and the reaction, this is the first step. This is the first video you need to understand very well before not for you to what understand everything about what aldehyde and ketone. So let's get into it. Now we're talking about aldehyde and ketone. What do you mean? Now, aldehyde and ketones, they are a class of organic compounds that have the same functional group, which called the carbonyl functional group. So now, because they have the same functional group, so they have similarities. So aldehyde and ketone undergo the same preparation and what and reactions, which I'm going to talk about later in the video. But before we look at NTA, let's look at what the carbonyl. The carbonyl is made up of what? Carbon double bonded to what? To oxygen. And there's a double bond here, which is what? Pi bond and what? And sigma bond. So every carbonyl are what? Pi bond and what? And sigma bond. So that what give them what? Their unique what? Characteristics, how they react and how they are being what? Prepared. Do you understand? So now, so if aldehyde and ketone have carbonyl function, so how do you differentiate them? Now, what you want to understand here is that in an aldehyde, in an aldehyde, now the functional group which is what the carbonyl always have what hydrogen attached to it. Do you understand? So there's always an hydrogen attached to the carbonyl function what in an aldehyde. So now there it can be an hydrogen or any other what carbonyl or any other what group, alkyl group. Do you understand? A good example is when you have CH3 C hydrogen. Do you understand? This one is what is an aldehyde because why? The carbonyl functional group is having what an hydrogen. If you look at this one here, hydrogen, and what hydrogen. Now this one is an aldehyde because it can what two functional two hydrogen. So as a matter of fact, this is called the simplest aldehyde. It's called methanol. Methanol. Do you understand? If I ask something like this again, CH3, CH3, CH2, C, hydrogen. If you look at this one here, this is also what an aldehyde. Why? Because the carbonyl functional group have what an hydrogen. Do you understand? If I see something like this, this what is an aldehyde functional group, right? Because this one is not an hydrogen, is what is a benzene attached to what is functional group and what an hydrogen. You get so this one is also what an aldehyde. You get so we are going to look at the various nomenclature. How do you name them as we move on in the class? So now if you talk about an aldehyde is having a carbonic functional with what with an hydrogen. Then any other group at all. It can either be alkene or what cyclohexene. Do you get that benzene or cycloalkene or cycloalkene? So this is what you want to understand very well. So now how do you know how do you get ketone? In ketone, look at something here. In ketone, now the carbonyl functional group do not have hydrogen. So the carbonyl functional group do not have hydrogen. It can either be alkyl and alkyl. You get so if you share the difference between an aldehyde and ketone, if share the difference between an aldehyde and ketone, yeah. An aldehyde, there's what hydrogen here, right? But a ketone there's no hydrogen. So whenever the carbon functional group is not having a hydrogen, is a ketone. This is called a ketone. So a good example is what CH3 C CH3. Now you can see that this carbonyl functional group here is having two methyl group, right? Now if you have another thing like CH3 CH3 CH2 C is the what as long as this carbonyl do not have any hydrogen attached to it is what is a ketone. Another example is this. Now this is a what this is a ketone. Two what two benzene attached what to a carbonyl functional here. Do you understand? So these are all what ketones. So we are going to look at how to what to name each of them one by one. So but we want to start what with the aldehyde. How do you name an aldehyde? So that is first we want to look at. Let's start looking at what the nomenclature of the aldehyde. So we're talking about an aldehyde. Now, aldehyde is a common name, and aldehyde is not what Alkanal. Do you understand? It's called Alkanal. It's been derived from the alkane. Remember, alkane is like this. Alkane, right? When you remove the E, you play with AL, it's called what? Alkanal. It's okay. So the modern name to most of the functional group is what is the alkane. Just for it to what make adjustment depending on what on the functional group. So we were talking about the aldehydes. The nomenclature you remove the E from the alkane and replace with AL, get what alkanal. So now let's start looking at what little example here. The simplest form of the alkanal is this, right? Two hydrogen. The carbonic carry what two hydrogen. So this is the simplest form. The molecular formula is CH2O. So now whenever I say CH2O is what is this one here, right? So it's called what? Methanol. It's called what? Methanol. Now the next thing we want to understand here is what CH2 C. What is all this guy here? Here we have two carbon atoms. Now whenever you have two carbon atoms in our case, it's called what? Ethane. So you remove the E, you play with AL. So you have ethanol. Now next we want to look at is what CH3, CH2, CH2, CH2. It's okay. So we have 1, 2, 3, 4, 5. 5 carbon atoms. Now 5 members of the alkane is called what? Pentane. Now since it's having functional here, the ideal functional group is now what? Pentanol. Pentanol. It's okay. Now if you have something like CH3, CH2, 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 C. Here we have 1, 2, 3, 4, 5, 6. Go to what? Hexanol. Now, one thing about the nomenclature of what of the IDI or alkanal, what I want to understand here is that the carbonic carbon is always what my carbon one. This is always what my carbon one. So my carbon one is 1, 2, 3, 4, 5. I get 1, 2, 3, 4, 5, 6. It's okay. It's always what my carbon one. So the functional is always carbon one. So the position of the functional is always included. Unlike the one we are going to see, in the ketone, you get. So now the main reason why it's always carbon one because it's always at the what first carbon, it's always at the starting point. So it's always like carbon one. So if for example here now have an idea carrying a what a substrate like this CH3 CH2 CbRO Cl CH3. So how do we name this one here? Let me write this place out. How do we name this compound? So therefore, you have to take the carbon chain that have what the carbon chain that have what more carbon atom and name it as the parent chain. Follow the rules of what nomenclature, right? 1, 2, 3, 4, 5, 6. So the parent name is already what hexane. Hexanol. It's also already what hexanol. Remember that this carbon atom will always be my carbon one, right? So it's going to be 1, 2, 3, 4, 5, 6. Now, you find that this compound have three different substrates. Here we have what the methyl. Here we have what the chloro, and here we have the bromo. Can you see that? So methyl, bromo, chloro, right? Now, when you are naming, you must name the substrates. You must arrange the substrates alphabetically. So account number 4, I have what bromo and what chloro. And account number 3, I have what a methyl. Bromo will come before chlorine, and chlorine will come before what methyl. You get. So account number 4, I have what a 4 bromo. So it will be 4 bromo. You understand? Then 4 chloro. Then I have what 3 what methyl. Then I have what hexanol. Can you see that? 4-bromo, 4-chloro, 3-methyl hexanal. So that is the name of what of this compound here. So remember, when number and alphabet must be separated by this hyphen here, this dash here is very, very important. You separate numbers and what and alphabet. So now let me give you one for you to try. Let me see what you can do. If, for example, here we have six. So go ahead and drop the answer to this. Drop the answer. Pause the video and name some for me. So you're going to be try one. Try one. So just say try one. You put the name of this structure for me. So let's go. Let's go. Pause the video and try it. Drop your answer at the comment section. Now, let look at it together here. Remember, here we have 1, 2, 3, 4, 5, 6, 7, right? So here we have 1, 2, 3, 4, 5, 6, 7, right? So we're going to be what? Heptanal, right? It's going to be what? Heptanal. Now, here we have a bromo group, bromo, right? Here we have what? 9-2. Here we have what? Methyl. Here we have what? Ethyl, right? So if you look at it very well, it's going to be 2-bromo, right? Now 9-2. Now here we have N, E, and N. So E will come before any other one here. Bromo will come first, right? When you arrange it alphabetically. Then E will come second here. At number 5, I want ethyl. So it's going to be what? 5-ethyl, right? Now, then M and N, which will come first? M come first in what in alphabetical order before what N, right? M N. So we're going to do what? 5 what? Methyl. They have 3-nitro-heptanal. So that is the name of this compound here. Yes, you can see how it is. Now let's look at the one that have. Now, how do you name an aldehyde that is directly attached to what to a cyclic compound? For example, here we have this one here. For example, here we have so how do you name this one here? So this is called cyclohexane, here called benzene. So hexane. So now whenever you see this one here, now whenever the functional pair, IDI functional pair is directly attached to a cyclohexane or alkene. Now the surface carbohydrate is always used. Surface carbohydrate. So carbohydrate is used. Carbohydrate. So the name of this cyclohexane is called cyclohexane. Cyclo what? Hexane. Cyclohexane. So the name is now going to be cyclohexane carbohydrate. That is going to be the name of this compound here. So it's going to be cyclohexane carbohydrate. Yes, that is name. Cyclohexane carbohydrate. So you have to work particular. You have to take note of this. If I have this one here like this, so what will be the name of this compound here? Now remember here you have 1, 2, 3, 4, 5. 5, right? So here you call cyclopentane. Cyclopentane carbohydrate. Just cyclopentane carbohydrate. So now and this carboatom, the kind of the functional is only of my carbohydrate 1. Just that. So if for example here I have something like this, let me write this place out. I have something like this. If for example I have something like this, so what be name of this guy here? Remember this one is what methyl, right? This guy is methyl. Now this one you're seeing here is what is a carbonyl. This one is called cyclopentane. So here go my carbonyl 1, 2, 3. 1, 2, 3, 4. So 1, 2, 3. So methyl is our carbon number 3. Now here's my carbon one. I can start from here 1, 2, 3, or 1, 2, 3. So that's the same thing. Or 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3, 4. So if here we give me what the lowest one. Remember, in the rule of nomenclature, what you want to put in your mind is that you must number in a way the substituent must have the lowest possible number. That is, the carbon atom that carries the substituent must have what lowest possible number. So that one of the key rules when you're what naming what organic what compound. So this meter here is a carbon number 3. Now remember the name of this I call cyclocarbohydrate, cyclopentane carbohydrate. So the name is going to be 3 methyl 3 what methyl cyclopentane carbohydrate. Just an 3 methyl cyclopentane carbohydrate. That is the name of this stuff here. You get. Now, how do we name this one here? The one with benzene ring. The one what benzene what ring. Now, whenever what a carbon what an aldehyde is directly attached to a benzene, it's called benzaldehyde. It's called benzaldehyde. Benzaldehyde. Very important. So it's totally different from this one here. It's totally different from when you have something like this. It's okay. Now this is called cyclohexane carbohydrate. Why is it called benzaldehyde? So please don't miss these two things here because students normally used to miss these 2 points. You get benzaldehyde. That is a benzene with an aldehyde functional group. That is the meaning. Now, if I have something like this, B what what be the name of this compound here? 1, 2, 3, 3 bromo, 3 bromo, 3 bromo benzaldehyde. What aldehyde. Or you can say M bromo benzaldehyde. It's okay. Times M means what? The what third position, right? So when you are studying what nomenclature of when you are studying the nomenclature of benzene, you understand that yes or M. I've done a complete video when it comes to the nomenclature of benzene. Complete video on nomenclature of benzene. So you can go check that video out. I will leave the link at the description below, or you see it up, or you see it at the end screen. Okay, now since we are done with an aldehyde, let's move toward to ketone. So let's look at what the nomenclature of ketone. Look at what the nomenclature of ketone. So how do you name ketones? How do you name ketones? Now, ketones is like this. I will say before. This is what ketone. Now, the functional group is not always carbon 1. For example, here we have CH3, CH3. Now, there's a little misconception about this one here. Or students normally used to have some few uh, misunderstanding here when I name this compound here. Now, the difference between this guy and this one is okay. Now, this one is what is an idea which called Alkanal. Think about 1, 2, 3. So we have propanal, right? Propanal. Now, but this is not propanal. This is called propanol. Propanol. It's okay. So, but now let me explain here. Now, ketone is also what alkanol. Yes, ketone is also what alkanol. You get alkanol. That is, it's which guy from the alkane. Now, when you look at alkane. Now, when you remove the E and replace what? O-N-E. Here we have what? Alkanol. Okay, so aldehyde and ketone are being derived from what? From the corresponding what? Alkane. So if you look at this functional pair, this functional pair is between two alkyl group. So it's called propanol. The position of this one here is not needed because there's no way you can get on that position apart from what this other one here to get what ketone. right? So if I have other something like CH3, CH2, CH3. Now, what be the name of this other one here? What be the big name of this compound here? 1, 2, 3, 4, right? And is what this functional group is between two alkyl groups. So here we have what? Butanol. This is that butanol. So that is the what name of what of this compound? Butanol. Now, Chris, I'm not going to put the position here. Now, there's no point of putting the position here because if I have something like this, CH3. So yeah, 1, 2. Here we have 2 butanol, right? If I also adjust to this side, here we also have 1, 2, 2 butanol. Now you're not going to start from here 1, 2, 3. It's going to be 1, 2, right? Here is also what 2 butanol. Do you understand? Now, do you know the reason why? Because the carbon atom that carries the function must have the lowest possible what number. And for you to have the lowest possible number, you have to start from here. If you start from here, we have 1, 2, 3. If you start from here, we have 1, 2. So here also what 2 butanol. What no? Here we have what 2 what butanol. So these are things you really need to what pay close attention to. So now let's look at difficult ones. So let's look at what difficult one. If for example here we have this stuff here, we have CH3, CH2, CH2, C. How do you name this compound here? How do you name this compound here? 1, 2, 3, 4, 5, 6. Now is what hexanone, right? But what the position of the what the functional here? If I start from here 1, 2, 3, here I have what 3 hexanone. But if I start from here 1, 2, 3, 4, 4 hexanone, right? So which one is the correct one? Is it this one or this one here? Now remember, according to the rule of nomenclature here, the functional group must have the lowest possible number. So this is what is the correct one. Now 3 hexanone can also be written as what? Hexa, hexa 3 what's on. They're the same thing. You get? So this and this, they're what? They're the same thing. Now, what about if you now have what? A substituent. For example, here we have CH3. Okay, now let's look at this guy here. How do we name this one here? Here my functional group, right? So you go to have the lowest possible number. Here we have 1, 2, 3, 4, 5, 6, 7, right? So we have this guy and we have this guy here. So here we have two substituents, two what substituents. Here we have what the methyl. Here we have the methyl. Here we have what cyclohexyl. It's okay. So now whenever cyclo is a functional group called cyclo what hexyl. Do you understand? So now the portion of this functional group here must have the lowest possible number. The functional group is what is my highest priority. So when you say that I will number it such a way that this carbon atom here must have what my lowest possible what number. So of course go to start from here. So it will be 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbon atom. So my parent name is called Alkanal, right? What the portion of this double bond here? I count by 2. So we have 2 octanol or octa 2 what's on. Do you understand? So I count by 4 and I count by 6. I have what inside. Cyclo C will come before what M. So the name is going to be 5 cyclohexyl, 5 cyclohexyl, then 6 what? Methyl. 6 methyl, octa 2 what? On. That is the name of this compound. You get? Okay, now let's look at these two compounds here. Now, you find that there's cyclohexane that is having what this one here, right? So here we have 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5. Do you understand? So these are going to be what a ketone, right? But it's going to be cyclohexanone. Do you understand? Cyclohexanone. Remember, if it's just this one here, it's called cyclohexane, right? But it's not having what a functional group. So it's going to be cyclohexanone. Very important. Now you're going to be cyclopentanone. Cyclopentanone. So the name of this guy is going to be cyclopentanone. Do you understand? Now, here going to be like 1, 2, 3, 4, 5. So here we have what ethyl or functional group. So here we're going to be 3 ethyl cyclopentanone. That is the name of this compound here. Very important. You can see how easy it is, right? Now, in for example, here we have CH3, CH double, CH, CH2, C, CH3. Now, what about if there's a functional group here? If there's a double bond here, right? Here's what is an alkene. Here's what is an alkene. There's a double bond. Here's what is an alkanone. Alkanone. So how do you name something like this? So that is next I want to teach you here, very, very important. So if for example you have a carbonyl functional and what and a double bond here, how do you name this compound? It's very easy. It's very easy. So I'm going to take you step by step. Now, normally, how many carbon atoms do you have here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? Now, if for example here you don't actually know how to name this here. Now let me show you step by step on how to do that here. Now, remember the six carbon atom, the six carbon atom in alkane is called what? Hexane. So go to start for what? Hexane. Hexane, right? Now, you not have two functional pair. The uh alkanone and what? The En, which is called what? The alkene, right? Now, this guy, the alkanone will take higher power than the other one here. So my main functional in this compound here is what? Is what? Alkanone, which called, yes, alkanone. That is the number I go to favor this one here, right? So we have 1, 2, 3, 4, 5, and 6. That is the carbonic functional with atom number 2. Now, 6 is an alkanone. What are you going to do here? You want to remove the E, replace with what? O-N-E. You understand? So it's going to be hexanone, right? Now, but it's a carbon number 2, right? It's a carbon number 2. So it's going to be what? 2 hexanone. So here we have, or you can say hexa 2 what? On, right? Now, but here we have a double bond here. A double bond is a carbon number what? 4. Now, this AN will change to what? EN. So that now because AN means what? A single bond. Now we now have a double bond, right? A double bond means what? E. So now what we change here is going to be this E. So it's going to be eggs. Now what is the position of this double bond? Is account number 4. So S4 in 2 what? On. That is name. So this is how to what? To name compounds that have alkene, either aldehyde or what? Ketone. So let's take on that one for you to understand. Let's take on that one so you get it clearly. Let's take on that one. If for example you have CH3, CH double bond, CH2. We now look at this guy here. 1, 2, 3, 4, 5, 6, 7, 8. Right? Octane, right? But here we have a double bond here. a carbonyl functional group here which called ketone, which called aldehyde, right? So the E will change to what? O-N-E, which called octanol. Now, although here we have two functional group here, this guy and this one here, right? But this one have higher priority. So the name of this now the parent name of this compound, the functional group is what? The parent functional group of this compound is what? Alkanone. Do you understand? So that is almost have what by lowest possible number. So I'm going to start from here. 1, 2, 3, 4, 5, 6, 7, and what? And 8. Right? So the name is going to be octa, or you can say 3 octanol, or you can say octa 3 what? Can you see that? But here I've not included what my double bond here. There's a double bond here at coming about what 5, right? So the A will change to what? E. Do you understand? The A will change to what? To E. So it's going to be three what on. But what is the position of this double bond here? I count about 5. So it's going to be up 5 in 3 what on. You see that? So that is the what name of this one here. It's very important to know all this what nomenclature. It's very important what you know all this nomenclature here. So I don't want to go too far and I don't want this video to be too lengthy. So we are going to end this class here. Now the next video is going to be what preparation. How can you prepare aldehyde and ketone? That will go to be what my next class. So if you're not subscribed to the channel, please hit that subscribe button. If you have any questions, leave at the comment section. If there's any bothering you, leave at the comment section too. I will respond to that. Thanks for watching. You can check other videos on I've done video on inductive fertilizer spread, hyperconjugation, optical what isomerism. You can check it at the description. They'll be there waiting for you. Thanks for watching. See you there.